Hi, I'm Trent Roberts, Soil Fertility Specialist with the University of Arkansas System Division of Agriculture. And today for my virtual corn field day stop, I'm going to be discussing fertilization practices in corn. There are three main things that I would like to cover today that I think are essential for a well-balanced and profitable corn production system in Arkansas. As we know, corn is becoming an increasingly important component of our crop rotations across the state. And what that means is that as it becomes increasing in acreage, we need to make sure that we are fertilizing it as appropriately as we can. Three of the things we want to focus on associated with proper fertilization of corn has to start with number one, and that is soil testing. So soil testing is a vital component of any fertilization program. And so what we really want to do is start out with a good solid foundation that involves routine soil analysis focused on those nutrients that we can categorize using our soil tests, and then use those soil tests to guide fertilization practices. The three nutrients that we're going to be most focused on when we utilize those soil tests are going to be phosphorus, potassium, and zinc. Those are the three that we have correlation and calibration data to support fertilizer rates based on soil test values. And so like I mentioned before, getting off to a good start with a sound quality soil testing program is going to be essential for profitable corn production. The next thing that I want to talk about is some of the work that we've been doing, particularly with nitrogen management, both mid-season as well as late reproductive growth stages. We've been collaborating with Larry Purcell looking at drone imagery as a way to predict potential nitrogen deficiencies around that mid-season, which we would typically call like a V10 or later growth stage, all the way up into our early R1 to R2 growth stages. So the component that I deal specifically with is going to be the use of tissue tests or leaf nitrogen tests to identify possible nitrogen deficiencies in corn production. And so one thing that is very important about utilizing these tissue tests is making sure that we sample the correct portion of the corn plant and we get the proper corn parts to analyze for tissue analysis. So when we look at this particular corn plant, it's obvious that it's well into the reproductive growth stages, but for our particular test, you can really start taking samples anytime after V10. Our particular interpretation is good from V10 all the way through the late reproductive growth stages. When you're in that vegetative growth staging timing, what we're really going to look for is the uppermost collared leaf. So anytime from V10 through about VT, what we're going to want you to sample is just the uppermost collared leaf on the corn plant. And that's very important because that particular corn leaf is the one that we've utilized to correlate and calibrate this particular tissue nitrogen test. What you'll find is that nitrogen concentration is going to vary greatly across the corn plant. And so making sure that you sample the correct leaf to use our interpretive tissue analysis is very important. Once we get to that tasseling growth stage or VT, you can usually identify the ear leaf at that point. And so once you can identify the ear leaf, we want you to sample that particular leaf from that point going forward. And so if you look here, we're calling the ear leaf this leaf that is immediately subtending the ear on the corn plant. So just to recap, late vegetative growth stages, we want you to sample the uppermost collared leaf. And for VT through reproductive growth stages, we want you to identify that ear leaf and then sample this leaf that's immediately subtending that ear. Now, when you do sample that leaf, we essentially want you to just break it off here at that collar, and we only want you to submit this leaf blade. That leaf blade is what will be dried and ground for analysis. So when we start to talk about interpretation of these results, what we've found is that 3% nitrogen is kind of the magic number. And so anytime from V10 through R2, our goal with our nitrogen fertilization program is to try and keep that tissue nitrogen concentration in either that uppermost collared leaf or the ear leaf above 3% nitrogen. And what our research has found is that when we can keep it above that 3% nitrogen range, we can ensure that you're maximizing yield as it relates to nitrogen fertilization in corn. The last thing that I want to talk to you about is zinc management in corn. And so whether or not we're talking about corn or any of our cereal crops, zinc management can become very important for maximizing yield and profitability. Zinc is most often going to be limiting on our high pH soils and soils that have low soil test zinc. One thing that we really want to encourage producers to consider is looking at ways to build soil test zinc over time. So in most of our production systems where we have low soil test zinc and we have high pH, our recommendation is going to be to apply 10 pounds of actual zinc per acre. This can be a very costly practice, and a lot of producers are a little hesitant to do that. But the one thing that we want to promote is this idea that if you are able to apply that 10 pounds of actual zinc per acre, what that does is it helps to build your soil test zinc level over time. And eventually, once you build that soil test zinc level, you don't have to keep including zinc in your fertilization program. So although it might be kind of expensive up front and it may take 2 or 3 years using that recommendation of 10 pounds of actual zinc per acre, eventually we're going to get to a soil test level where we no longer have to apply that particular nutrient. And so really when you compare that 10 pounds of actual zinc per acre to some of the alternatives such as foliar zinc in season, they tend to cost roughly the same amount in terms of the cost of the product and the cost of the application. And so the difference there is when we do the 10 pounds of actual zinc per acre pre-plant, that's going to help us build soil test zinc. Whereas when we're doing the foliar application in season, yes, that does correct and prevent deficiencies, but it does nothing to help build or increase our soil test zinc over time. So what we really want producers to start considering are ways that they can implement, zinc sulfate pre-plant into their production systems to help build that soil test zinc over time, with the goal of eventually getting it to a level where we no longer have to apply zinc to those production systems to maximize yield. So once again, 3 things I want you to remember about corn production as far as it relates to fertilization or soil fertility. We want to start off with a good sound soil testing program, and we can use soil testing to really guide our phosphorus, potassium, and zinc needs in corn. We've got a lot of tools for nitrogen management in corn. So using our ear leaf tissue test is a great way to determine whether or not you need additional nitrogen to maximize your corn grain yield. Along those same lines, we're finalizing some work where we can use drone imagery to help predict that tissue nitrogen concentration as an alternative to the actual tissue test. And then lastly, zinc management is very important for our corn crops. Anything we can do to build soil test zinc is going to be like putting money in the bank that we can rely on later. I'd like to thank the Arkansas Corn and Grain Sorghum Promotion Board for their support of all of our research, and the Arkansas farmers for their support of our research. And if you have any questions, always feel free to ask. Thanks.